Hello, everybody, and welcome to today's PS Day event. It's such a huge pleasure to have you all join us for today's technical talk, and we're really grateful and excited to have you all here with us. This technical talk has been organized to celebrate the IEEE PES Day. My name is Adedoyin Olaji. I am a PhD student and a graduate research assistant at Florida International University, and I will be your moderator for today. Also with me, I have a co-moderator, Hassan. Hassan, would you please go ahead and introduce yourself?
Okay. My name is Sweta Gupta, and I am from Afghanistan, and as an IEE PS ambassador at the IEE Kabul section, and I am as an undergraduate degree at as an undergraduate at Mechanical Engineering at Karachi University from Afghanistan. Thank you so much. Thank you.
Thank you. Well, the theme for this year's 2021 IEEE PS Day event is the Clean Energy Revolution. And this theme is more relevant today than ever before, as we all work together in reducing our carbon footprint, all the while having a reliable and sustainable and resilient energy system. And for that today, I have the pleasure of having a very distinguished guest to bring us a very insightful and valuable topic. But before I go to that, I would like to give a few housekeeping details. Today's technical talk is going to be recorded, and so that we can send out the recordings to everybody at the end after the event is over. Okay, so please keep that in mind. And then at the end of the technical talk, so the technical talk will be for about 30 to 45 minutes. And at the end of that, we would have a Q&A section, which will be facilitated by Hassan. So please feel free, to put your questions in the chat box, and they will be attended to at the end of the event. Or you'll be given a chance at the end as well to unmute yourself and ask your questions if you prefer to ask your questions verbally. Okay, so without further ado, I would like to read out the bio of our speaker for today. I'm going to share my screen. Okay, so I have the huge privilege of introducing our speaker for today, Sweta Gupta. Sweta is a graduate research assistant pursuing her PhD degree in electrical and computer engineering from Florida International University in Miami, USA. Prior to working at FIU, she served as an executive engineer in a 2x500 megawatt coal-fired thermal power plant at Damodar Valley Corporation under the Ministry of Power, where she represented the organization at national conventions and central power sector undertakings. She graduated from NIT Amirpur with BTech in Electrical and Electronics Engineering, and thereafter a master's in power management from University of Petroleum and Energy Studies in India. Besides integrated academic and professional work experience, her travels has inspired her critical thinking, which she continues to apply in her research with smart materials and brainwaves. So with a round of applause, I present to you Sweta Gupta. Over to you, Sweta.
Thank you, Adi, for the wonderful introduction. Appreciate it. I will now go with the presentation for today. So, can everybody see my presentation?
Yes, we can.
Awesome. So, here we go. A well-run project is a little like a referee at a football match. If he or she is doing good, you probably won't notice it. If it is a successful project, you probably won't hear about it either. A very good morning and a very surreal good evening to people present here who have their precious time out to be here with me together, and we can discuss our ideas and have a perspective on the impacts of power plants on environment. So our mother nature, before I start this, I would like to show you a video. Are you able to see the website of the conference? Or
Some call me.
No, we can only see your PowerPoint slide.
then I will just shift, thank you. So here we go.
Mhm.
Sure. Others call me Mother Nature. I've been here for over 4.5 billion years. 22,500 times longer than you. I don't really need people, but people need me. Yes, your future depends on me. When I thrive, you thrive. When I falter, you falter. Or worse. But I've been here for eons. I have fed species greater than you, and I have starved species greater than you. My oceans, my soil, my flowing streams, my forests, they all can take you or leave you. How you choose to live each day, whether you regard or disregard me, doesn't really matter to me. One way or the other. Your actions will determine your fate, not mine. I am
Yes,
made
are you taking screenshots?
to evolve. Are you?
So that was a small about Mother Nature, how powerful it is, and it actually does not need us, but
The Our Planet series, launched on Netflix in April 2019.
thank you. So that was Mother Nature for us, and this is our world when it gets lit. So this is our India, Afghanistan, Miami. So everything of the world is lit by beautiful power plants that we have in the surroundings. But there is another flip side to it, and this is what it is. The power plants are actually emitting a lot of pollutants to our nature. With each passing day, it is causing a devastation and havoc to the nature. As we can see in the landslide and the glacier that have unleashed carnage on workers and residents in Uttarkashi in the recent Himalayan tsunami that occurred in February 7th, you can see the water, the glacier broke, and the whole power plants were just disrupted and washed away. And it not only wiped the communities that lived there, it wiped the power plant just like that. So that's the power for Mother Nature for you. And these are baboons. We just see their animals, but these are the animals who actually died when there was a Texas power outage, a sudden glacial cold storm, which everyone knows about it. Well, we were sitting and enjoying electricity at our homes. There were animals who actually died in the process. This is the financial market that crashed, and maybe it doesn't seem much because the point jet flipped were just like 5 points, but when your price of share market is just not much, a five drop is a significant change and can cause a lot of things to happen, which we just see in graphs, but in person it can actually devastate things and people, and even cause deaths, as we have already observed and seen and heard from the news. So the topic for the discussion today is impact of power plants in environment. So I am narrowing down this discussion to power outages to focus primarily towards it. So what does it mean? What does a tripping mean? So this woman is trying to open the light every now and then, but if a power outage happens, she is in dark. So this is pretty much a power outage. On a very good evening night when everything is good, we like to observe and see the sprinkling and the mesmerizing lights and sit around there, and everything is dancing, partying, lights, life, energy. But what happens when a power outage happens like this? It turns out to be a dark, romantic 14 February night, as it happened on the Texas power outage happened on Valentine's Day. So definitely it had a sign for us to go back and revisit our love for nature that we have. So after everything happened, this is a short overview on how a control operating system look like in a room. The pressure at that time for the operator is to the max. The person does not can get off from the enormous pressure that is happening. He has to, the person who is responsible, he has to supply power to all the areas and make everything green and not just a black or a rolling blackout. This is not acceptable. So this is a power plant, and this is the control room where I was working in. This is a 500 megawatt unit for one side and another 500 megawatt unit. And as you can see, these are two cooling towers. And people do sometimes think that the cooling tower that emits a lot of vapor and steam, it is actually causing pollution. But this is not true, as it is a cooling tower. It is just condensed cooling water in normal phase, like basically it is circulating water for it to go to the structure and gets cools naturally, and in that process it emits water vapors. So this is a water vapor and not pollutants. And one more secret I would like to tell you today is that if you would know how dense this vapor is, see, this is quite a little bit less dense and this is more dense. So when you see a power plant from a distance, you can see that what is the humidity of the area, because if there is a lot of humidity, this thing is not going to end up here. It's going to go straight to the environment and then condense somewhere where where it is allowed to do it. So this is a trick a person can, who lives near power plants or goes around it, he can say the humidity of the area very well, if it is very humid or less humid. So this is a layout of a thermal power plant. It looks complicated, and it is complicated, but it is a fun. If you would just join me today here with from the coal to electricity, I would like to grab your attention, and let's go from coal through the conveyor belt and how the electricity and smoke is produced. So let's see. This is coal, who is in coal handling plant, which comes from the trains and tracks, and then it goes through the coal conveyor to the bunker where it rests, and then it goes from here through the PA fan, which carries which has air, a lot of air, and then it goes to the furnace where it is burned, and when it gets burned, it releases a lot of emissions, which goes from air preheater to ESP, which is an electrostatic precipitator, and then via this through ID fan, which is induced draft fan, through chimney, which is a 275-meter high, maybe a 75-story building, and to the air. In that process, it heats the water. So the air and the flue gas cycle and the water cycle is in one furnace. So when it heats the water and steam, and it gets a temperature and pressure that we need in 1,000 megawatt power plant, then it rotates the turbine and the generator and the exciter on the same shaft, which causes it to rotate at a 3,000 rpm, which means if this turbine decides to go nasty and the protection system fails, then it can disrupt with its blades the complete community, the area, and everything. The blades are so huge. And then when the steam condenses and finally relaxes to form water into a closed loop cycle, the water goes back to the cooling tower that I showed you, and just to cool the steam that we have produced, we need a lot of cooling water, and that cooling water actually helps to cool the steam and get the cycle back rotated. And this is pretty much about a coal power plant, on how it functions. And rest of the equipments that are added are basically added to increase the efficiency of the power plant. The maximum we can get is like 35%. So these are the various tripping that can happen. Tripping, as I indicated, is because when we are not supplying electricity to the grid. So there are many methods that can lead to unit tripping: man, machine, method, and material. In this presentation, I'm going to cover three methods that are, one is this with machine, one with material, and one with man. So this is one short slide that indicates the head, the causes that can lead, the sub causes, and then the sub causes. Just imagine the material failure at a welding joint can also lead to tripping, and that's not a short tripping. That's going to be tripping for maybe 36 hours sometimes. And going a little bit into a technical side of how a power plant reacts when it trips. So this is a generator. There are turbines. There is a drum. There is a derailleur. There are compressors, and there is a receiver tank. So how it behaves in conjunction, I'm trying to depict in this slide very shortly with help of animation. So when your boiler drum, which is at 85 meter, is going to have a low level of water that can go to form steam, then a unit should trip. Because if it does not trip, that means it is not a good protection system. So when it trips, it's good, because otherwise our drum will starve with water. And then why it is happening is because all these pumps, they fail to open and supply water to the drum. It is possible, very much possible. Let's go and see why. It's happening because there is a pressure tank that was helping to hold the pressure of the valves to circulate the water from deaerator to the boiler drum is not working because there is not enough pressure. And why it could have failed? Oh, the compressor stripped. It can happen all the time. And the whole process is a timeline. If it starts at time 0, then the drum and the generator would trip maybe in 10 minutes. It depends situation to situation, but everything has a reaction time. Just like when we learn to drive, we have a reaction time on which speed, what brakes has to be pressed to stop at a particular point, something like that. So this is unit outage and oil consumption that happened during that particular tripping. This is real-time data. So on July of 8, yeah, this is Indian time, and in the morning we had an alarm, and the tripping lasted for 35 hours. Then that's a cold tripping. That means we have to shut down everything. We have to restart from the scratch. We have to heat the furnace that was heated, giving electricity at 500 megawatt earlier, and now is at 0. So we have to make the unit go and thrive back again. And this is light diesel oil, heavy fuel oil, and startup and stabilization. So startup is when you need to give your unit a push, because the ignition temperature at inside the furnace is cold right now. So we need to raise the ignition temperature by giving a low viscous fluid, and which is oil. And oil is the same oil that you fill your cars with, and the consumption is not much. It's just 110 kl, which is 29,000 gallons. So just for one unit to revive it back, I think for one plant, it's just too much of pollution. And this is not just the air pollution of, or the, the oil is, we understand it's a scarce resource, we have to use it optimally and everything, but there are other resources also that we have to consider. The auxiliary power consumption. I am having no income, and having all the expenditures. I have food, I have rent, I have grocery and everything. So it's not going to work out if I do not have an income for myself. Same is with power plants. Power plant does not have going to generate. If it's not going to generate, it's not going to feed itself. It's going to take power from outside. When it's going to take power from outside, it's a debt. And when it's a debt of 75 megawatt hour multiplied by some cost that is very huge. So that accounts into the picture when it comes to calculations. And this is for unit 2. This is a trend basically that is taken on a screenshot, which indicates that the actual load, the basically when the unit is coming back, and all the parameters of the mill, that FD fan, CW pump, that are not needed. They have to be run to maintain the parameters of a non-operating unit, you can say. And the impact of problem is not just one fold. It's huge. It's direct monetary loss. Declared, you cannot declare your capacity. You cannot say that I'm going to generate 1,000 megawatt with a 0 megawatt producing unit. You cannot capitalize on unscheduled interchange. You're not in a market, period. Indirect monetary loss, heavy oil consumption, additional, you have to give it more power consumption, as I just mentioned in the last slide. We have a loss of reliability and credibility. After the Texas power outage, ERCOT definitely lost a lot. We will see it. We have seen it in the stock market, and it just happens. People do not like to rely on somebody who does not can give them electricity at the times of their need. So this is also one slide that I really wanted to show you. So now, till now, we have seen that there is a technical aspect that can cause tripping. Fair enough. Now let's see the second aspect, the lack of preventive maintenance that can cause tripping. We have studied that all these beautiful rivers and power plants situated, giving humidity indications and transmission lines. That's all good, looks to me. This is a power plant. When we see from the sky, it's in DSTPS Andal where I worked. So the water reservoir, these are two water reservoirs. This is the national highway, and we used to come from here to here entrance, and this is restricted facility. Not anybody can enter because there are lots of explosives and the chemicals that operate under certain protection. These are two powerhouses. These are the railway tracks from which the coal comes, which I mentioned in the layout. And then there's a coal yard where the coal is stacked for it to be blended, to be fed, or in times of emergency, we need to have a stock. On a particular day, a 1,000 megawatt power plant can consume 14,000 metric ton of coal, which is quite huge. And this is ash pond. This is nasty because just like humans, we have to get our system and particles get out of the body. The same way the power plant also emit its waste through ash pond, and it accumulates here, but it also is adverse to our environment. And this is the front view when you come from the highway and you look at a power plant on a night. It is huge, 275 meters chimney with 85-meter of boiler and 260. This is huge, this cooling tower. And this is what we actually do. We are I can't say much on that, but I would definitely like to show you a PF fan which is covered in coal that is thrown from the conveyor belt from the top. So reality and expectations can be can have a very wide band gap, you can say. So this is the third slide that was that I assembled for uh, depicting defect due to welding. So as you can see, this is a very small defect, but it is happening here. And when this is a water wall tube, and it's inside the boiler. You can actually walk when the leakage happens. Suppose the leakage happens here. So now there is a manhole here. The person enters, he builds a scaffolding here, and then you can walk all over the place, and it's pretty dangerous. Some people actually get injured, but this is the work that requires not only expertise, but also requires endurance. So, and it's fun. So burning money and climate change. Tripping. Why did I choose this topic? Just because when a unit is tripped, it is uh, okay. As I mentioned in the layout, the electrostatic precipitator are the ones that separate the cold the part the dust particles, or the suspended particulate materials into the system, and these are harmful. So the ESPs are designed to capture the emissions to a particular nominal level. But the disadvantage of this ESP is that it cannot be charged. It cannot be charged until your flue gas temperature reaches to approximately 130 degrees centigrade. And that's because to avoid the sulfur sulfuric acid formation at low temperatures, which is possible because the pollutants contain sulfuric oxides, and those pollutants can actually cause acid formation. You can always see that in at the tips there would be always oxide formations and corrosions happening. So when the plant is stripped and is trying to come back, it is unregulated. It is emitting whatever it wants to emit, and it is not less. It is beyond. It is beyond. It just looks like this. Trust me. And these are the economic impacts for a 1 megawatt deviation that you achieve because you have not every time you trip the unit, you are protecting the system, but or at the same time you're compromising with the efficiency of the system. So if you are compromising with the efficiency of the system, you're making a loss, and when you are making a loss, the loss is from all these aspects that technical parameters can contribute towards, and these are just the inefficiency loss. It's the monetary loss that cycles back. Okay, and this is the health impacts. It causes respiratory disease. How many people I have seen have died just because of working in the power plant there. Historic structures, Taj Mahal, it's destroyed from the acid rain. Climate change, Himalaya tsunami, Texas power outage. Am I saying less here? Affects water quality. Well, the pollutants you are emitting is going somewhere. I will better depict in the later slides. Then fishing of marine species, true. Crop cultivation is affected. Then plant growth is affected. Then livelihood of farmers and fishermen, because these people do not know what's happening. These are the people who are given compensation for giving the land to the government to build projects, but they are not given compensation for their kidneys, for their lungs. Now it increases risks of accidents due to hazardous working conditions. Air pollution, SOx, NOx, carbon monoxide, SPM, acid rain, smoke. I can't emphasize much on the harm of these pollutants and how long they stay in environment. So this is the power plant I'm coming from. It's near Kolkata. It might be somewhere in here, but near Bardhaman, Durgapur. So this is data captured from the AccuWeather. So that says how much is the air quality. You can see here we have very good quality, but here it's a coal bedded region. Most of the coal are found in this region. So this region is inhabited by power plants. Result, you have a good idea today. So this is more specific. The Durgapur, West Bengal. Then I have gathered some data from Kabul yesterday and from Miami. So Kabul and Miami, we are good, but Durgapur, we have created an unhealthy atmosphere for generations to come. It causes irritation, coughing, breathing difficulties, and asthma. And people who work in that region is just an observation, but they do smoke a lot, so that just aggravates a lot in this already smoked environment. So pollution is due to water pollution, land degradation, and noise pollution. It is just ever increasing. So in the figure I showed about the aerial view, I showed you the ash pond, but in this figure I'm going to emphasize how beautifully it is merged with the ecosystem of our nature. Do you think it's possible to not permeate these harmful suspended particles into this river? Of course it's possible. It's going to just be there. And the noise pollution, when you enter the power plant, the noise pollution is beyond 85 decibels at many places. workers work there. They have limitations to work, so that affect their health and the living conditions and the environment. And I would rest the slides for today, and thank you. And just to end my message, be so happy that when others look at you, they become happy too. Thank you.
I have a question.
Yes, Professor.
So, how often is this tripping happening?
Okay. The tripping of a power plant, when it comes to an existence, that is commissioning of a power plant, then it can trip from anywhere high, and it can reduce exponentially. But for a typical power plant in first year of commissioning, it can face up to 30 trippings. And the primary reason it encounters is just because it's like a child that has entered into the world, and it is allowed to do mistakes. And just like as humans we adapt, the plants also adapts. It understands, okay, this is an area which has more moisture, it needs to be done, uh, put some protection. The system has, oh, this wire got wrong, oh, this signal is not connecting, oh, this person stole this metal. So the reasons can be all sorts of ambiguous reasons, but definitely they can be reduced depending on the place it is operating, the person who is operating. And of course the AI is going to win over on reducing the tripping for future generations to come.
I want one more question. If I'm a professor, I have questions. So you gave us a trip, I think it was 35 hours. Is that like typical, long, short? How long are the trips?
The trip, there are multiple type of trippings. One can be short tripping, and one other could be trippings that are longer in duration. So the short trippings are like hot startups, they say. So when you have a unit that got tripped just for a flame failure, say, then it can recover in 3 hours. And people compete on these numbers, because the faster you get the unit into service, you get appreciation a lot, because this is something that every individual in the power plant gets messed up in his head. Oh, what is happening? It's like trying to bring back a child into life again. They are so much into it, but sometimes you do not know what to do about it. So we categorize these things. So in hot startup, it's like furnace is hot, we just have to achieve the parameters that just fall off and start the unit again. And in cold startup, just like in boiler tube leakages, then it gets very bad, because then you have to shut down the complete unit, let it cool down naturally. By not naturally, we do operate the fans to get it more circulation, but still you cannot force beyond a level. So it takes a lot of time depending on where the leakage is. If the leakage is happening in the reheater area or the plate and superheater area, these areas are hard to reach. You have to build a scaffold to reach in, and the person who is going to do the welding, he needs to feel comfortable to go and work there. And so it takes time, and it's very difficult to pressurize on those conditions, because these are real conditions. And so that can take up to 36 hours. Sometimes it takes, if there is no cold, it can take 10 days, 15 days for a plant to come back. And sometimes in overhauling, we shut down the unit for That's the biggest. Overhauling is like you need, after a certain amount of hours the unit has run, we need to relax. Just like we need to refresh, the unit needs to refresh, rejuvenate, get its part repairs, and get back healthy so that it can be back into the same level which it was designed for. So.
Hey, dear participants, if you have any other questions, please text here in order to answer them. Thank
I have one quick question, if I may.
Yeah.
you. Yeah, you can go ahead.
Yeah. So I saw that the ash reservoir is right next to a like a national park, right? And I was wondering, is that I'm guessing that's not normal, and why is that allowed, or how did the ash reservoir get there?
I really appreciate the question. And how does it go there? What we are seeing in this level is just one example of what happened. And how it goes there, I will tell you a story if you would like in this. Okay. So I was working in a power plant, and there were some inspection for coal quality and the amount stored. So the inspector came, and there was I think it didn't happen in my area, it was in another plant. So there was an representative from our plant, and the inspector comes and say, where is the coal? And the representative answers, don't you see these cows? They have eaten all the coal, because he wrapped the coal with the sugar and let the cows out so that it can have that of perceived effect that it is eating the coal, and they believed it. So this is one of the things that happen, okay? And these are the things that I'm telling you from the experiences that I have encountered. So why it happens is that we are not aware of our nature. We are not, we just have this so much privilege and liberty, and we do not realize how unhealthy things can get. And it's like it comes back. I'm going to emit something that is going to stay in an environment for 50,000 years. How the hell am I going to supposed to escape from it? There is a lack of maturity, you can say, to to coordinate these events to the level that we pay for it. Okay. Yeah, there is definitely a gap to it. So to answer your questions, there are positions, there are environmentalists who come and try to close, but sometimes they are not in their uh, things escape. They do not escape everywhere, but if you consider the large picture, we are definitely impacting our environment in several ways that we do not know. We just see things, oh, everything is good, the electricity is white and yellow, and but electricity there is, air is bad, very bad. I have breathed that air a lot.
Thank you.
Thank you so much, Sweta, for your very informative presentation. Actually, I've never worked in a power plant, but you were able to paint a very vivid picture in my mind. So thank you for that. I have a question actually, specifically with regards to the power plants where you worked and India in general. Are there specific like practical plans, to go more green? Since you talked about the, the impact on the environment, on health and all that. So what plans are there, do you think, to kind of reduce all these emissions and have a more sustainable?
Once again, I really appreciate the question because I have a quite perspective about it. So, in one of the meetings that I attended, they were trying to talk about the sulfur dioxide removal, the SOx NOx removal plants. That they said that would cost 1 crore per unit per unit of electricity that we are going to generate, which is a huge financial impact. I think it's $1 million or something. So to invest in something like that, it takes a lot of finance. First. Second thing, the plant is running at a plant load factor. Plant load factor is something that if I have a 1,000 megawatt power plant, I'm just trying to run it at 700 megawatt. So my PLF would be 70%. So they do not run a good PLF, which is a desired of 85%. They run approximately to 60%, 70%. It's because they do not have coal, they do not have demand, they have lots of outages and everything. So that the complete cycle makes it very non-feasible to think of something to go extra edge first. Second thing is the area. The area on which this power plant is located is a coal bed area. So coal is so much into that area that it makes it an economical choice to opt for it. Still, the attempts are being made for solar and energy to harness more, but these power plants do have a future there, I would say.
Awesome. Thank you. Does anyone else have questions?
Okay.
I have. I can't help myself. I have an inquiring mind. I think you said it was two 500 megawatt power plants together. And I'm wondering, when one of them trips, does it ever happen that both of them are tripping at the same time? And what happens with that?
The case study that I presented was that both of them happened at the same time. So it was a total power failure. That made it more worse because I do remember I was there on that day. And what happened in the early morning in the first shift, they were my friends, and there was some problem that was there. The unit was showing the indication as boiler drum level low, as you guys saw. So they got freaked out. What's happening? And the attempt is to save the unit. Do whatever you can because it's $1 million right there. So what they did, they in order to save the unit, they didn't check the protection. They didn't see what's happening actually. So when they went to close the breaker to get the steam from the other unit also tripped because there was a fault in the electrical line and that was grabbing a lot of current. So the breaker, and there are two breakers and there are separator plates, and the moisture in the plates was to the extent that it conducted, and when it conducted it caused fire actually in that complete area. So before inspecting the thing, you go and close the breaker and cause the tripping. This is something that happens. I am not going to decide on why it happened, but it happens. Things happens, and this and when that happens, your steam line, it falls into the temperature, so it's very difficult to revive a unit back after that. And moreover, if in India we had in 2012, I believe, the whole blackout thing happened, and it was basically where the government allowed the consumption to as much as they want people, and they didn't want to curtail. There was just an excessive demand, and it leads to the collapse of the grid. So this is something that do happen. I hope that answers the question. Okay.
It does. It makes me want to move to an island with solar and get away from all that stuff. Thank you very much for the presentation. I have to get to a class now, so I'm going to have to leave, but I appreciate the presentation. Thank you.
Thank you for joining us.
Oh, it was fascinating. I mean, I got to admit, it's scary. I would be, I think I would be afraid to work in a plant like that with all that. And she says so joke serenely, oh yeah, when it tripped, there was a fire, a huge fire, and like, yeah, we have that all the time, no problem. Million tons of stuff is flying into the atmosphere. I'm like, oh, give me a break. Let me back to my teaching job. So again, thank you to the speaker and thank you for moderating, both of you. And I'll catch y'all later. Keep up the good work. There's lots of engineering to do in this world.
Mhm. Thank you so much. Bye.
My pleasure. My pleasure. Bye.
Okay.
Okay.
So does anyone else still have questions?
Yes, I do.
Okay, please go
Okay,
ahead.
this is piggybacking off of the professor's question. You mentioned that the tripping occurred, that you were referring to both plants going down at the same time, right? Okay, so when this occurs, you got the blackout, right? Everybody's without power, and how long did you say this was? And are there backup generators of some sort, or what happens to the people who actually need energy, electricity, power, like respirators, things of that nature, you know what I mean?
I get what you're saying. The situation in that case, I come from India where the power is not very much into every person's lives. So people adjust. And second thing is that in case of high emergencies, the power is, if you do not, if you have power demand of 100 and you are having 50, you cannot just produce something and fill 50. Okay. So what they do is they prioritize when they have to cut off the lines, just like in the rolling blackouts they did it in line. They just do not cut off the hospital supply or the supplies. They do not like to kill people. Basically, they like to do it in sequence so that there is less loss of life in that scenario.
Okay.
And yes, the power outage, if that gets a complete blackout, it is very scary, because even in the power plants, you do not have a communication to talk with each other, because the lines get disrupted, because we have lines that are not mobile. Only the mobile works at that time, and that too sometimes places do not have signal where you need to close that huge valve. So everything is dark, especially when the blackout happens in the night time. So sometimes, when the blackout happens, things are going crazy. We thank God that okay, it happened at this time. It's the situations are definitely, but they are experts in the areas that know how to tackle, but still they have to be tuned to achieve to a certain time limit, I would say, to
Yeah, I can totally relate to that actually, because I'm from Nigeria and power outages are like a part of our life. Like it's a normal thing, you know. So most times we rely more on, small backup generators. So basically every household that can afford it has a backup generator. Like, so at night when there is no electricity, the entire city is noisy and loud, and there is a lot of pollution in the air. And then people who can't afford the backup generators rely on lanterns, lamps, candles, and things like that. And so even hospitals, critical infrastructure that actually need this electricity always have backup generator.
Yeah, that's true. I recall one of my experience from my childhood. My father, he is here. My mother is also here today with us. And they're hi, Papa, Mama.
Oh, they are here.
Yeah, and they came to support me. So I was
Oh,
an incident today that when I think I was working. I was in my school life, and my father was in power plant, and he has served power plant a long time. So he was working there, and what happened? A tripping happened, and he was there for 43 hours straight. So the life I have seen with my father working so dedicatedly and with the responsibility, because people, what happened, they just come and sit in the power plant outside, we want electricity. So there is a pressure on engineer side, we have to get the thing done. Electricity is like oxygen now, if you understand what I mean. So people do work, and my father is definitely an inspiration for it.
Awesome.
All right. Well, thank you for answering my question. I appreciate it. Your presentation was very nice. It's actually made me consider power. I wasn't even thinking about power before.
Oh,
That's something that made my day.
It really sounds interesting, very fascinating.
I'm very glad that I was able to achieve it. And thank you, Addie. I would.
thank you. Actually, for me, I'm also a power systems engineer. And honestly, the power outages in my country is actually my, motivation, was my motivation to actually go into electrical engineering and study power systems. Because, in this part of the world, sometimes like electricity is a part of life. So we don't really know what it means to be without electricity. But, in countries like India, Nigeria, there is usually this, like whenever electricity comes in my country, for example, there is just this joy. Like even if you're not using the electricity, like it's not like it's daytime, right? It's not like you need the physical light or something, but just knowing that there is electricity, like there is just this joy and happiness that is in the atmosphere. Everyone is just happy, and I just wanted to be a part of that, to see how I can be a part of solving the problem. So your presentation, Sweta, was very insightful, because I've never been in the power industry. I've never worked as in the field. I've just been on the academic side of things. So it was really good to actually, see what goes on in the industry. So thank you so much, Sweta.
Thank you. Okay.
Okay, guys. So we still have time for more questions if anyone has questions. Okay, so in the absence of more questions, I would like to thank everybody for attending today's technical talk. I really hope, I think one of our participants mentioned that this has inspired him to look into power industry. So I hope this was a valuable and productive time for everybody. Thank you so much for joining us. Actually, this is part of PES Day, and we'll be having one more event next week, Tuesday. That's April 9th, I think. Next week, Tuesday, we'll be having another event. So I'll also be sending that out to everyone, and please feel free to join us if you're interested. Thank you so much, Sweta, again for such an inspiring presentation. I learned a lot, and I hope everyone will have a great rest of the day. Bye.
Bye. Thank you.